Hi, good morning. In this lecture video, we are going to discuss about topic on convection in heat and mass transfer. In this video, we are going to discuss about topic on what is convection, what is forced convection, uh, Newton's law of cooling in forced convection, what are the parameters involved in the forced convection, and different types of flow dynamics in forced convection and applications of the forced convection. Uh, in heat and mass transfer, there are different types of modes in heat transfer. The one is conduction, convection, another one is radiation. Conduction is a type of heat transfer in which the heat transfer occurs within the medium or different medium when there is a physical contact between two solid bodies. In radiation, the heat transfer will take place with the help of electromagnetic waves. Coming to our topic, the convection is a type of heat transfer which occurs between solid to liquid medium, liquid to solid medium. However, the transition medium occurs only with the help of only fluid medium. The key concept in the convection, it combines the effects of conduction within the fluid and advection, bulk fluid motion. What is the mechanism involved in the forced convection means there are two types of convection. One is forced convection and another one is natural convection. The natural convection which relies on the principle of buoyancy. However, the forced convection uses the external forces to move the fluid. The primary drivers in the forced convection are fans, pumps, blowers, and wind. The diagram clearly shows on the hot surface the forced air was allowed to touch the hot surface, which makes there is a change in temperature, which clearly it is the example of the forced convection. Next, Newton's law of cooling. In convection, the temperature occurs between the hot temperature to lower temperature. So the heat transfer was calculated by Newton's law of cooling, which was given by Q is equal to H into A into del T. Del T is the temperature gradient because the temperature flows between uh, surface temperature to fluid temperature. It was given by Ts minus T infinity. Ts is the surface temperature and infinity is the fluid temperature. H is the heat transfer coefficient and A is the area. Next we will see about the topic on heat transfer coefficient. Um, in forced convection, the value of heat transfer coefficient was slightly higher than the natural convection. Uh, Heat transfer coefficient directly proportional to the rate of heat transfer, but inversely the area and the temperature gradient. The heat transfer coefficient was mainly influenced by the fluid velocity, turbulence, and mainly physical properties of fluid. Next, we will discuss about drivers of the forced convection. In forced convection, the drivers are fans, pumps, blower, or suction systems. Next, we will see about the external flow dynamics. In external flow dynamics, the fluid is forced over the unconfined object. Example of the external flow dynamics is air over the vehicle or cooling fan. Next, internal flow dynamics in forced convection. It occurs when a fluid is forced through a pipe, duct, or channel. The best example of the internal flow dynamics is addition of heat exchangers and HVAC systems. Next, the force converter mainly used in the thermal management in computers because the CA in In computers, the CPU fans were used in which forced convection was used to remove the heat from the heat sinks to prevent hardware damages. Let's come to the summary of the session. In this video, we'll discuss about the convection. Convection is a type of heat transfer which occurs between surface to fluid or fluid to surface. But the heat transfer occurs only in the occurs only with the help of fluid medium. Next, the formula for the convection was given in terms of Newton's law of cooling. The different type of dynamics in the force convection are external flow dynamics, internal flow dynamics. Um, the best example of the force convection was mainly used in the cooling of the modern electronics, especially in the computers. Thank you.